Hello, I'm Ryan Jones, and this is Coffee with Ryan, episode number 3. It is about 4:30 on a Saturday, and so I do not have coffee today. I've already done 2 coffees. Also slightly a little bit under the weather, throat-wise, so I'm going to try to do a little bit of this. Maybe it's not the best idea. Hopefully the audio is coming out okay. But yeah, today we're going to be looking at serverless Twitter. I've got a Corona, which is what you're supposed to drink when your throat hurts. Just so you know. Oh my gosh. Okay. All right. So we're good. So today we're gonna be looking at serverless Twitter, some top posts, let's go ahead and just jump in. So the first thing that we see here is Tom Milner. This is his first blog post as an AWS community builder, so congrats to that, Tom. This is on how to build a serverless data API with AWS AppSync and DynamoDB with the YAML included. And also credit to Sebastian here for the AppSync example. And then he also tagged Jason Dunn for the AWS team. So let's go ahead and dive in. All right, so building a serverless data API with AppSync and DynamoDB by Tom Milner, and written very recently on May 21st, which was yesterday on Friday. So the first thing that he's going to get into here is kind of an overview. So it says, please find below a tutorial to create a serverless data API using AWS DynamoDB as a backend data store and AWS AppSync to create a GraphQL interface. All the steps and code examples shared are defined in a YAML. I've used the AWS SAM syntax where it's supported and CloudFormation where it's not. So let's kind of get into it here and look at what's going on. So the first thing he's talking about is a DynamoDB table here. So you can see a screenshot here. This is the CloudFormation syntax for creating a DynamoDB table in YAML format. With every AWS CloudFormation resource, you're going to see this type of definition here under type. And so we have the AWS DynamoDB table. This could also be a Cognito user pool, it could be RDS, it could be a VPC resource. And then each CloudFormation resource also comes with the properties. And so here you can see a couple of properties. The high level, we have table name. So this is going to be the string value of what the table is actually called. This is the human readable version. Then we have provision throughput. So with DynamoDB, you have 2 different options. You have read and write capacity, which is kind of like 2 different dials. Read capacity, it's how much reads per second. It's basically enhancing your DynamoDB capability for that table, with the caveat being that you're probably going to be charged more for that extra capacity. So when you use provision throughput and you have read and write, and you're using these 2 dials and saying I'm going to set my capacity units at 5 and my read capacity at 5, you are kind of provisioning those. And so they also have another one, which is pay per use. And that one can be nice when you're just playing around in a dev environment. And what's going to happen is that if you get no requests, you pay nothing for the table. Whereas in this scenario, if you had read and write capacity as 5 and 5, you might have a very small bill if you're not under the free tier of AWS. Then we have attribute definitions. So it looks like here we've got the PK and SK. So PK stands for primary key and SK stands for secondary key. In DynamoDB, you have a primary key, which could be like, let's say, user ID or ID or something like that. And then you have like a type maybe, which would be your sort key. And the type could be, this is if you're going to do like a single table design potentially. If Alex O'Brien ever watches this video, he can correct me, or anyone else for that matter. But so like when I played around with single table design, you'll have a primary key and then you'll have a secondary key. And that second, like your like ID, it could stand for multiple things, and then your secondary key could be a specific type, so that you can have records of different types inside the same table. And that could be something like user ID, organization ID, and so you have the initial ID, and then you might have a second field because it's no SQL, so you can have as many columns as you need, and you can add those as you're going. So with that, you have org ID. And let's say it's like, SG, and then I have a user, I have an org record, which would be like Serverless Guru, and then an org ID of SG. and then I can have another record, my second record on that table be user ID, and it could be Ryan, and then it could be Ryan, a Serverless Guru, and then it could be part. Then it could also have an org ID field on the user record, so it would say org ID SG, and then now there's a way for me to basically connect those two records together, and that data lives in the same table, but the type, which is the sort key in this scenario, that sort key would be how you can actually filter through the table. So I could say, give me all of the orgs. So inside of, maybe give me all the orgs, and so I could get back, SG, and I could say, give me all the users, and I could flip the type to users. And so in that scenario, my first record is type org, and my second record is type user. And then I could have I could have 20 different user records, all with the same org ID of SG, and that kind of allows it to like connect back together. And then of course on top of that, you can get even more advanced and have secondary indexes, and that's just a way of basically splitting up your data to make it more searchable, and allows you to move fields around. So maybe I could switch my sort key to be, I can make my primary key the org ID, and I can make my secondary key something else, and you can do that with secondary indexes to allow you to search the data a little bit differently. It's honestly, it took me a spreadsheet, and I was like color coding and all that stuff, and it's kind of it's an abstract thing to wrap your head around, just talking verbally, but there are ways to do it, and there's people out there that are much better suited to do that than me off the top of my head. So yeah, buy Alex DeVry's book. And then going on, we have key schema. We have the attribute name here of PK1, key type of hash, and SK1. I'm going to talk about this just now. Hold on. So this is important. It's important because with DynamoDB, I've been saying primary key and sort key, but then we also have hash and range, and there's also like composite keys, which I believe is both primary key and sort key together. So there's a whole bunch of vocabulary, and I think that's where stuff starts to get a little bit confusing. And same thing with read and write capacity units and like understanding how that works. So this is another example here. You can see that the way it's been labeled is PK1, SK1, but then the way that DynamoDB understands it is hash and range. And so for this case, a hash key type is your primary key, and the range key type is your sort key. So that's kind of how that works there. And that's why, it can sometimes be pretty jarring when people first jump into DynamoDB and see all the different nuances of it. That is very much different than something like a MongoDB or Firestore, for instance, if you're familiar with GCP. All right, IAM, you need to create a number of AWS IAM policies and roles to allow AppSync to access both DynamoDB table and log to CloudWatch. So let's go down a little bit and look at that. So we have AppSync to DynamoDB. So once again, I forgot the name of the author. Tom is showing us how to do an IAM policy here with CloudFormation. You can see that it's a policy. DynamoDB is the name of it, and the type is AWS IAM managed policy. And if you remember up here, we had the type of AWS DynamoDB table, and so that first word is always AWS. The second word is the service, and then the third word would be the actual specific subcategory of the service. So for instance, IAM has managed policy, but it also has like users or user. And so you can create an AWS IAM managed policy, or you can create an AWS IAM user. And both of them would have the same, most of it's going to look the same, and then that last part is going to be different based on what you're trying to do. And then once again, we have the properties section here, and that was the same as the DynamoDB table. And you have attributes underneath it, and these ones are going to be the ones that are different. And what I've noticed is even on comparable services, I don't know if this is because AWS has two, like they say the two pizza teams, sorry, my brain, two pizza teams, which is basically like the entire team should be able to be fed off of two pizzas. I don't know how much this still is the case, but regardless, what I've seen happen is that even names, like here, for instance, like path, we'll see an AWS IAM managed policy that it's called path, but then we might see a different service that has a similar functionality, at least in terms of like what you're doing, but then it won't be called path, it'll be called something else. And it might be called name for the service, excuse me, but then in a different scenario, it's called like role name or it's called table name. And so this isn't as much relevant, but if you're ever trying to create automation around using AWS CloudFormation and you're trying to predict what those fields might be based on logical things like, oh, 7 services use name, but then other services use role name, that's where it gets really tricky. So just calling that one out in case it's ever something that you're working on. And then moving on down, policy documents. So policy documents in IAM are always going to have a version statement. And the version is typically just set as 2012 10-17, and this is pretty much always the case. I'm not sure if this will update in the future, but at least all I've seen is it be 2012 10-17. And then we have statement here. Statement has 3 properties, and this is going to be the case pretty much always as well. You'll have effect, which will be allow or deny, and so allow means allow, this. Whoever's using this policy, allow them to do these actions on this resource, right? And so if this was deny, then we would say deny whoever's using this policy to do these actions on this resource, right? So we can do both allow and deny policies, and we can define actions here. The first part of this action, it says DynamoDB. This could be Lambda, it could be RDS, it could be any service that AWS has. So what the point of this one is it's allowing, this is a policy DynamoDB for AppSync. So what we're trying to do here is we're trying to connect AppSync to DynamoDB, and in that way, we need to make sure that AppSync has permissions to do a query, get item, put item, and delete item. And you can see here that, oh man, I believe it was Tom. Yep, so you can see here that Tom is using a sub command here, and the sub command has some $ brackets here, curly braces, and what this AWS : region does is it dynamically swaps in the region during when the CloudFormation is compiling. And so what'll happen is that it'll say, make this deployment to AWS, and then based on where I'm making the deployment, what region, this value will automatically swap in. So it'll change it from $ curly brace AWS : region to US East 2 or US East 1 or US West 2. Then after that, we have a dynamic reference for the account ID. So it's going to do the same thing as the region that we just talked about. Based on what account you're deploying into, it's going to swap that value in. And then we have table here. And then finally, we have the DynamoDB table name. And he's using the syntax to reference DynamoDB table. So I'm assuming that there's some other code in here in his CloudFormation stack where he's actually able to make this reference. So I don't think that we've seen this get defined yet. We can see here using a ref function, which is a CloudFormation function, which allows you to pull in a field from the top level of CloudFormation into the actual CloudFormation resource definitions. And you can see that here with the ref API name. And you can see it here as well with the DynamoDB table name. So ideally what's probably happening is that he has something inside the CloudFormation towards the top, which actually defines these 2 dynamic variables. And that's how he's making the reference here. Okay. So moving forward, we have using STS assume role to attach the policy to the AppSync service. You can see here we've got role AppSync DynamoDB, and this is an IAM role, and you can see it's referencing the policy that we just created up above. So this IAM role is going to have this policy, which allows these actions on this resource. And this resource is a DynamoDB table. And you can see once again we have the version statement here, and then we have the statement, allow, STS assume role, and appsync.amazonaws.com. So this is pretty much boilerplate. The part that we're changing is this policy here. But the STS assume role, it's allowing this IAM role to basically work with AppSync. So what's nice is that something like this can be kind of complex to set up. I don't think I write this by hand very often. Typically, inside the IAM console, you can get a lot done just by looking at generating an IAM role first. This is probably how I would go about doing it anyways, is that because you want automation, but at the same time you want to make sure that you're not wasting time trying to just fiddle around for the sake of fiddling around. And so I would go into the IAM console in AWS, and then I would try to create this role and this policy, and then I would try to test it, of course, through the console. And once I know that it works, I would then put that into infrastructure as code and make sure that it's like completely accurate based on what I set up in the console. And then I would try to duplicate it. So that saves me from trying to fiddle around with the infrastructure as code. Maybe I miss that it's Amazon AWS, and I just put appsync.aws.com versus appsync.amazonaws.com. That's something I would do locally, but in the console, it's going to autofill that in, and then I can just copy that locally into my infrastructure as code stack, and yeah, and then from there, I can make sure that I'm spending the most amount of my time on actually developing the stuff that's different or that's worthwhile. Next, we're going to give CloudWatch log permission to AppSync, and so Tom is setting up another role here, and there's also a managed policy here. So we can see policy and then service-role, and that was what he called this policy here, service-role. So he's referencing that, and then he's saying AWS AppSync push to CloudWatch logs. And again, appsync.amazonaws.com. And this setup here, this setup is nice, and also something where you can see that from this is an IAM role, this is an IAM role, from this one to the CloudWatch one, they're pretty similar. There's some small differences like the managed policy ARN. You can see that he's referencing the policy DynamoDB here, and this one he's referencing an actual full path. However, it's nice because we can copy paste most of this and then just change like one value here, and we can just keep creating IAM roles. So that's where you start to get that momentum effect with infrastructure as code. At first, it's a lot, but then as you get going, you can build up templates, and then it gets easier and easier over time. Okay, so next up we have AppSync. So let's go ahead and dive into that. So it says here that we need to create, what am I reading? Yep. We need to create the following resources to have a fully working API. The first one here is API header, and then we have API schema, data source, resolvers, and API key. So I'm not going to run through this one. You can pause the video and read this yourself, or go to Tom's article, I'll link it. But let's just dive into this and we can talk about it as we go. So the first thing we need to do is create the actual GraphQL API. So this is the API header that he's referencing. So once again, this is a CloudFormation way of deploying this. There is a serverless framework version where you don't have to define each individual AppSync resource. However, if you were going the CloudFormation route, the stuff that Tom's doing right here could be probably pretty easily copy-pasted and then very easily modified. So first one here, we have AWS AppSync. So remember AWS for CloudFormation. The second one is the resource, and then you have GraphQL API. Properties here, we have the name reference, which is a reference function. So as it says, you basically define a variable up top inside the CloudFormation stack. So it's basically a file, and in that file you have YAML. You have this inside of a file called x.yaml. At the very top of that file, you have a variable called API name. That variable is something, it's just a string value, and it could be Ryan's API. And so then when I use exclamation mark reference, it's basically saying, go to the top of this YAML file, grab API name, which is Ryan's API, and swap that in for the name here. So now the name of our GraphQL API for AppSync is Ryan's API. Authentication type with AppSync, you have a few different options. The one that Tom is using here is API key. This one is a good one to start, and the AppSync console in the AWS console does a really good job of making it very easy to test. And in a lot of cases, this is sometimes what causes issue when people are first getting started with REST APIs and they're trying to test through something like Postman, is they don't know specifically how to call the API key if they put private on API gateway for creating that REST API. And you can easily get into a scenario where you just kind of put yourself in this scenario where you have to figure out all this stuff. And it's not a bad thing. Everyone has to go through it. It's probably actually a good thing, but it's just something that it sounds easier to do, and then once you actually get into it, and then you're like, oh, why is X dash API key not working? Or I tried to use a capital API key or something like that, and why is it not connecting? But in the AWS console for AppSync, they have a little query panel where you can actually very easily make those queries. And actually, if you have API authentication, it may not require this if you're in the console directly, but for something like, let's say your AppSync API had a Cognito, which is a authentication type that's a little bit more advanced than API key, it would actually allow you to make that authentication inside of the query console before actually making the request. Whereas with Postman, you would have to make an actual login request and then actually get back a JWT token and then actually attach it. But when you're testing inside the AppSync console on the AWS console, it's a lot easier. So you can just basically type in a GraphQL query, make the query, and if there is an authentication type on your GraphQL API, it'll like allow you to do it right there on the spot. And that's really nice for when you're trying to develop. All right, log config here. We've got the CloudWatch logs role ARN. We've got a function get attribute. This is the get attribute CloudFormation function. They're called intrinsic functions. Reference is one, get attributes another. And you have a way here with get attribute. Basically, this first word here, role AppSync CloudWatch. This is the name of the resource. So if we scroll back up, you can see that here, role AppSync CloudWatch. And then we have something called .arn. ARN is an Amazon resource name, and it's basically an address. And so what we're saying here is get the address of this role, and that allows us to connect it. So what it basically returns back, the ARN, which I believe he had an ARN here. This is what it looks like. An ARN will have ARN : AWS, and then the service, and then a whole bunch of other stuff afterwards. And they usually keep pretty similar formats. But just that's something to remember is that these types, so AWS IAM role, and most AWS CloudFormation resources have a get attribute function where you can actually pull back some key metadata from the resource by using just this simple syntax here. And you would want to do this because things change, right? So some ARNs might have the region or the stage inside of the ARN. And depending on how you make your deployment, if I was just saying ARN : I was hard coding it like that, this would change. And we don't want to reference a static value ever in our infrastructure as code, because when we do, we open ourselves up to future changes breaking everything, right? And so we want to make sure that we're always using dynamic variables. And to do that, you can do something like this where you're saying role appsync.arn. That way you're always pulling the most up-to-date ARN value. Or you can do something that Tom did earlier, which is the AWS region or AWS account ID. And so these are always going to swap in the correct value, and you're not going to get into a situation where you built all your IAC to go to US East 1, but you didn't have it dynamically switching for US West 2. And so then you would have to go into your infrastructure as code files and then, Command F, search for the different, US East 2, and then swap those out one by one to be US West 2. And that's a terrible process, especially once you start getting into like 100 different files, and they all need to be updated, and it just gets really messy. And so this can take some time to refactor if you're already doing it the hard-coded way, but over time you're going to get all that back and more. And so it's worth the investment to refactor your infrastructure as code to use dynamic values, because at some point it's like investing, right? You invest into something and you get back a return. At first, maybe that upfront investment is a lot, but then maybe a couple months later, you've actually paid off the investment and now you're making a return on it. And so this is a case where I would say the investment to do the dynamic variable swap and learn about that is worth it, even though it's going to cost some development time. It's going to save a lot of time downstream. So, okay, let's keep going. In this case, he's saying exclude verbose content, false. Verbose would be, basically printing everything. So he's basically saying, don't print everything. Actually, he's saying exclude verbose content. So he's saying, I think, print everything. And he's saying field log level is all. So it's not error, and it's not, I know one of them is error, and one is all, and I think there's one more maybe. So in this case, he's saying print everything. Okay, moving down to API schema. This is where things get, this is where things get interesting. There are ways to reference an external, inside of a YAML file, there, at least in serverless framework, there's a way to reference an external file, and that external file could actually be a GraphQL or schema.graphql file. I don't so much like defining schemas inside of YAML. I know this is a tutorial post, and so I won't harp on it too much. But that's like one thing that that's where it gets into like showing the way to do everything sometimes is like too much to cover, and so I understand where that's coming from here. But in a case where you're building something for your team, some GraphQL schemas are going to be, oh gosh, I've seen some schemas that were like, not saying that they're good, but just I've seen some that are like 5,000 lines, I think, a GraphQL schema.graphql. Yeah, it's giving me like Vietnam flashbacks. So anyways, going on, GraphQL API schema here, AWS, the first word, : AppSync, that's the service. GraphQL schema, that's the specific category underneath AppSync. So this is a resource of AppSync that's required. We have properties here, like all CloudFormation resources. We have API ID. So we're saying function get attribute GraphQL API.API ID. This is another case where if this was hard-coded and we put literally API ID 123, if we ever changed our API or make it a redeployment, that would still say 123, but now the actual API ID is 456. And you know what happens? Now we're in this weird state where like we have to then go back in and then update API ID to say 456. And hopefully that's we only reference that API ID once. Most likely it's referenced 10 to 100 times, and it gets really messy really fast. And deadline pressure is, can sometimes cause these type of things to be done, and they end up causing a lot of problems later on. So don't do this. Like do what Tom's doing. Don't do what I just described, where you hard code it. Moving on down, schema, we have query and mutation, which is standard. You also have subscription that you can add into the schema definition here. So I don't think Tom's getting into AppSync subscriptions here, which is for real-time connections. We've written some stuff over at Serverless Guru on it, but it's a whole deep dive topic in itself. So just know that that's a thing that you can do. With AppSync, you can set up real-time GraphQL connections. I believe behind the scenes is running AppSync's automatically setting up a WebSockets connection, and then you're basically just defining how AppSync actually connects with the front end to make that bidirectional stream of connections, so you can send data and receive data using that subscription. So I'm not going to go through the schema line for line, but it's looks like it's pretty standard stuff. Actually, if y'all haven't seen it, then I'll just talk through it, I guess. So schema query, so we have a type of query, and so if we go down here, you can see type query, and then we can see read data and read all PK data. So these are functions underneath the query type, and then we have arguments here, just like you would write in a JavaScript function. You have PK1, that's the first argument in this function called read data. Then you have SK1, that's the second argument in the read data function. And then you have the return type, and the return type is data. And so you can see up here we have type data. And you can see that he's saying data and then has a bracket, AWS JSON. So this is like the lazy way to do it. I do this a lot as well, is basically just say like it's gonna return back like JSON. And sometimes I'll just stringify it. And then that way I don't ever have to like set the types, because a lot of times with GraphQL, it's like AppSync has a lot of power. The GraphQL schema definition can sometimes slow you down if you don't fully know what you're building yet, right? So sometimes you just want to get your hands on code and start trying to see what comes to you, and building POCs really quickly, or building POCs where you don't know what the schema, like you don't know all the fields, right? So like defining name, address, name is a string, address is a string, phone numbers, a string, and like going through one by one like that and defining the fields. that's the right way to do it. But sometimes, if you want to just start building something and actually seeing it working, you could do something like this, where you basically just set a field like data, and you say AWS JSON, and that just basically means pass everything back. Yeah. All right, and the same thing for mutation. It works the same way. Here you've got an input argument, and you got a input type. So you can see write data input, and you see write data input here, and it's got a definition as well. And then they all return the type data. So, except for this one, this returns data collection. So that one's there. And this one's returning a set of items. And there's a next token because when it gets back from DynamoDB, it's going to have a cap on the number of returned records. And so he has next token set here so that he can pass the next token ID that DynamoDB gives back that Tom can then use to then paginate through all the data one by one. All right, moving down to data source, we've got another data source, or we got a resource here called GraphQL data source, AWS AppSync data source. We've got get attribute here, so again referencing the GraphQL API ID, another point of why it's important to use dynamic fields and not hard code anything. Then we have reference API name, another example. We've now referenced API name 4 times. And so all we have to do is update it in one place, and it updates in 4 different places, and that's amazing. The data source here is type of Amazon DynamoDB, and what this means is that it's going to, basically we're connecting this data source to our DynamoDB table that we defined earlier. And so we're giving it the service role here, so you can see, again, function get attribute, service name or role AppSync DynamoDB.arn, so it's connecting that to the AppSync DynamoDB IAM role that we created up above. And then we have the DynamoDB config, so we have table name, and you can see he's referencing DynamoDB table, which is the table resource that he defined earlier. And then he's subbing in AWS region here for the region, so he doesn't have to hard code US East 1 or US East 2, and that allows things to be a little bit more flexible. Now to resolvers. Moving to resolvers here. You can see the AWS AppSync and then resolver here. You can see depends on GraphQL API schema. So this depends on syntax is a way for you to basically modify the order of operations for CloudFormation. So sometimes you want a certain resource to be deployed before another resource. And most of the time, maybe like 90% of the time, CloudFormation does this for you automatically. But then there's some moments where what you're trying to do was not accounted for, and that's where you need to do a depends on statement. And so in this case, he's doing a depends on for the GraphQL API schema, which is basically saying deploy the schema first and then deploy the resolver. Because if you deploy maybe the resolver first before the schema, it'll break. And so he's able to basically tell CloudFormation new information and say run, you were going to run it like 1, 2, 3, but instead run 1, 3, 2, 4, if that makes sense. Okay, type name query, and then field name is read data. So if you remember, we saw a field earlier, that function we talked about was read data, right? So if we go back up to the query here, we see the read data function. And you can see now how that fits back in. So now if somebody makes that query for read data, it's going to trigger this resolver, and this resolver is going to have what's called a mapping template. The mapping template is going to do an operation, a get item, and you can see here we got key, PK1, and SK1. It gets pretty deep here, so let me see if I can give like the high level of what this is going to do. Okay, let's just go into it. So with mapping templates, and this is another one where using the serverless framework AppSync plugin, you can actually move this mapping template into a .vtl file. And what VTL is velocity templating language. And velocity templating language is just kind of it's like JSON, but it allows you to run functions or make calls to stuff. So you can do for loops, you can call stuff. He's going to get into it in just a second. One of them, though, that I'll call out is this util function that he's doing here. So this util function is actually something that AWS created. And so if you're inside the AWS console, you can actually go to the AppSync console and go into the resolver, and you can actually start typing in mapping template stuff. And if you type in $util, you'll start seeing it auto generate a whole bunch of options. One of those options is DynamoDB, but there's a lot more in there. And then you can say to DynamoDB JSON, And it's like, this is where we get into like, like serverless cloud, cloud development is complex. It's because of stuff like this. Because there's all these caveats, like why, right? Like you might ask, why, Ryan? Why are we doing this? Well, what Tom is accomplishing here is he's basically allowing us to connect to our database and make queries to the database without ever having to have backend code, right? So that might be like, what? That doesn't make sense, right? Normally we have a EC2 instance and we're running an Express app, or we have a container and it's running an Express app, or we have a Lambda function and it's running Node.js, just straight Node.js. Well, in this case, it's using this little JSON snippet here to get an item out of DynamoDB dynamically using this $context.args.pk1. So let's just focus on PK1, SK1. Where are these values coming from, right? These values are coming from this AppSync definition up here. So you remember when we talked about read data, and it's a query and it's a function, a GraphQL function, and has 2 arguments? That's PK1 and SK1. So when our front-end developer makes a query using the read data function and passes it PK1 and SK1, these are going to flow in automatically to the mapping template. And then this mapping template is then going to automatically connect to DynamoDB using a get item operation, and then return back to the front end the item, right? No backend code, no Node.js, no Python, no Golang, nothing like that, right? It's just a direct connection and back from DynamoDB. So we're able to get data out, and moving on down, we're able to update data. We're able to create new data. You can see creating new data here as well. And you can also delete data. So delete data here. All without having any backend application code. So all using BTL, and as he points out here, Apache Velocity Templating Language. So this is amazing, and this is so useful. It's like what Tom just put together is actually really spectacular, because he has examples for the full CRUD functionality. So getting items, getting multiple items, querying items, updating items, creating new items, and deleting items, as well as get and get all. And so this is the full rundown of stuff here, including some much more complex ways. Like this type of mapping template, it looks very complex. However, once you get into it, it's a little bit more, a little bit easier. The one thing that we probably need to call out is like, when does this go too far? So when does defining these mapping templates? First off, we wouldn't be defining these mapping templates like this inside of the actual YAML file. We would break it out to a separate file, and then we'd import it in, just to make it a little bit easier to work with, versus doing it in this format. However, it gets too complex pretty easily. I mean, for some stuff like get all, delete item, update item, and very basic update item operations, it works, right? You can do the direct connection to DynamoDB. It works great. However, if you find yourself in a situation where you're trying to do, let's just say, for loops, right? Even though you can, if you find yourself doing that, that might be going a bit too far, right? And so there are some things that you can do here, but in this case, if we're gonna use what Tom wrote and we're gonna modify it for our own purposes, we go, okay, I want to use what he did for write data. I'll copy the GraphQL schema resource. I'll copy this API schema, or this API resolver for write data. And instead of PK1 and SK1, maybe I'm going to call my stuff different. So I'm going to say, instead of PK1, I'm going to call it something else. SK1, I'm going to call it something else. And then down here, instead of PK1, I'm going to call it name. Expression is name, name, and so on, right? And so you could do it that way as well. That's you may not want to do that, but that's just an example there of that. The PK1, SK1 are pretty much the only values that change in this equation, and it's all dependent on how your actual GraphQL function works, right? So whether it's a mutation or it's a query, however it works and how much data it needs is going to change how you do all this stuff. So for simple stuff, CRUD operations, it's great. Once you start getting into more complex things, that's when you probably want to break out that Lambda function and actually write application code. But if you can get away with just doing this VTL here, and for the operations, which makes sense, then you're cutting out a lot of testing time, debugging time in the future, maintenance, updates, all that stuff. So it's, if we think long term, if we think 6 months or 2 years versus thinking today or tomorrow, that is a huge value. Plus the cost factor of it. When this is actually running, it's not actually triggering a Lambda function invocation, and we're not being billed for it, from my understanding. So the VTL setup directly to DynamoDB is not being billed, whereas if it went to a container or an EC2 instance or a Lambda function, you would be getting billed for that, and so there's an extra cost there. And then finally, we have the response mapping template here. So again, we're using this like helper library from AWS, which they have, and you can check this out in the AppSync console, and it's saying util.toJSON, and then it's saying take the result of making this request to DynamoDB. So if we delete item, DynamoDB might give us back like an ID or a confirmation JSON, and it's going to come back as a result here always. So we're basically just saying return back whatever DynamoDB gives us straight back to the front end. And then from there, the front end can then use that data and so on. And I'll show you, even for the get item one, it's the same. So here, Tom is making a get item request using PK1 and SK1 that's dynamically being fed from the front end request. And then you can see context.result. It's just basically saying when DynamoDB makes a get item using these two values, it's going to come back with JSON that might say name, address, phone number, email, and that's going to come back as result. And so all we're saying is context.result. And we see $context and you see $CTX, it's the same. It's just shorthand. So Tom could have wrote $context in full form up here, or $CTX down here, and it's the same. Whenever you're trying to pull stuff in or pull stuff out of this VTL format, it's typically coming out of the context and shorthand CTX. All right, moving on down, we've got API key here. So we're creating a resource called AppSync API key, and we're saying it's get attribute GraphQL API, and then API ID, so another example of the dynamic value, and then expires API key expiration. So again, he's using a reference intrinsic function for CloudFormation here, and he's set a variable at the top of the CloudFormation file called API key expiration, similar to API name, and then that's a field that's a string value, which is then being referenced throughout the CloudFormation resources. So define it once and use it multiple times. And then finally, we see the parameters here. So we have API name, type string, and API key, expiration, type number. And what ends up happening is that when he actually makes the deployment, he tells the CloudFormation, AWS CloudFormation, my API name is Ryan's API, and my API key expiration is 10. And then that gets fed into the template dynamically. So you can imagine we could have parameters for stage, we could have parameters for region, and we could have parameters for whatever else we wanted. And then those all could get fed into our stuff automatically. All right, then we got outputs down here. So we got API key description. So we can see that here, kind of already gone through a lot of that. But outputs in CloudFormation allow you to link stacks together. So you have one stack, stack A, and you have stack B. Stack A creates the API, and then stack B has a Lambda function which is going to use that API. And so to connect those together, we could say output the API ID of stack A, and then we can say function import value, which is how you basically pull it in CloudFormation to stack B. So we say function import value stack A dash API ID, right? Or however we call the output in stack A. Then we can import that value into stack B. And that way we don't have to hard code the API ID. And that's what all this is about. At the end of the day, we're just trying to make something that's very high automation. And to do that, we need to be able to basically connect them across. Looks like I'm getting a warning here on my my stuff, so I'm just gonna roll through a bit faster. You can see down here we've got a mutation definition, so you can kind of see how he's actually creating these requests in a little bit more detail. So he's constructing input data using query variables, so you can see that down here. So write data input, update data input, PK1, SK1 data, and then what actually comes back. So it's actually showing you what comes back here. And then you can use these to read data. So PK1, DBS1, read all PK data, DBS, and then it comes back like this. And this down here, this items, and then the open bracket or open curly brace, these fields are basically just saying, this is what I want returned when I actually make this query. I want these fields back. And that's it. Yeah, so kudos to Tom Milner. Thanks for letting me being the subject of this video. Really appreciate it. Hopefully, I thought this article was fantastic. So great job writing it and showing how all this stuff works. It can be very complex, and there's a lot to learn. And I didn't even go through all the stuff they talked about. So definitely give Tom Milner some hearts here on dev.to and some love on Twitter. And yeah, let's. I think I'm gonna go ahead and wrap. I mean, we've only done one article today, but I mean, we could read a couple here. Here's one from me, I guess. Anyone know an independent technical recruiter around the AWS or serverless space? So what this is about is that Serverless Guru, we're growing very rapidly, and the same stuff that Tom Milner was describing here is some of the stuff that we do for clients. And so we're trying to hire Node.js developers with AWS serverless backgrounds, Python developers, Python developers with serverless AWS backgrounds, and C# people that have some AWS serverless experience, AWS experience for C#, and then we could probably help a little bit with the serverless side. But really, we're just scaling up over here at Serverless Guru, and we're looking to find somebody that's a technical recruiter just to help us go through some of the ideas that we have around how to do recruiting. Like, I think there's some ways that aren't utilized as much, because ultimately it's not about just like getting people to work for the company, because that's just evil motive, which is sometimes the way that recruiting gets like looked at, especially from the engineering side. Like when I get inundated with like recruiting messages, it's not great. The type of recruiting I'm talking about is like, let's make a whole bunch of content publicly for the community, and let's make it super valuable, and then make Serverless Guru like a no-brainer to work at, right? Because you get to be part of a culture that's doing that, and then you get to be on that platform and then help, basically push your own content and help like push the community forward, and know that the company is like trying to really, really do that in force. And so, yeah. Going down, we got Alex DeBry here. Interesting updates in Postgres 14 to improve performance with lots of connections. This will help some serverless folks. Very cool. So give that a look. I'm just going to read a couple and then wrap up. Containers in AWS Lambda. So by Varun. I'm sure this is a great article. If I had more voice, I would get into it. So apologies for that. Dear serverless folks, apply for this. We need someone on the inside. I saw this the other day. I thought it was really funny. So Ben Kehoe is saying to this post by Matthew S. Wilson, which I'll follow him too. He's saying, we're looking for a principal developer advocate to join the AWS Kubernetes team. This team builds and operates Amazon EKS, providing our customers with secure, flexible, and highly available way to create, manage, and operate Kubernetes clusters. And so why he's saying that is because Ben Kehoe is one of the biggest serverless advocates out there, not for AWS, just in general. He says, dear serverless folks, apply for this. We need someone on the inside, which is basically like someone's got to get the inside scoop on the Kubernetes stuff, just to see what's going on. Yeah, I think let's leave it there. So really appreciate all the feedback on the last 2 or 3 episodes of Coffee with Ryan. I'm looking forward to doing this a little bit more frequently. It's unfortunate that I got, I won't say sick, because sick's kind of like that's like, who's really sick? I don't know. So I'm not sick. I just, I have my throat is, not great at the moment. So anyways, I don't know why I'm ranting on this, but thanks for watching. This was Ryan Jones from Serverless Guru. This was Coffee with Ryan, episode number 3.